In many construction projects, land excavation is necessary for various purposes, such as building canals, creating water sources, or reaching stable soil for loading. This process is known as excavation.
Excavation can be categorized into two types, unlimited and limited. Unlimited excavation occurs in areas where there are no neighboring structures. Once the location has been determined, excavation begins. The weaker the soil, the greater the angle of excavation must be to prevent the collapse of the excavation walls. The minimum angle is 5 degrees, while the maximum angle is 45 degrees. Unlimited excavation can also be performed using a layered system, where excavation is conducted at different heights, maintaining an angle relative to the vertical line similar to the previous method. In contrast, limited excavation is employed in urban environments or when adjacent properties are built. Due to the pressure from nearby buildings and other factors, there is a risk that the retaining wall may collapse or deform during limited excavation. To mitigate this risk, specialized systems must be implemented. One such system is anchorage. In this method, wells are dug at specific intervals along the edge of the site. The depth of these wells should be 25% greater than the depth of the excavation to withstand the pressure exerted by the surrounding soil. First, a steel reinforced grid is carefully positioned at the base of each well to provide structural support. Next, multiple steel sheets are precisely welded to the end of a beam, which is then meticulously lowered into the well. Once the beam is in place, concrete is poured into the well using a tremie pipe to ensure uniform and controlled placement. After all the wells have been dug and the concrete has been placed, the excavation phase can begin. This phase may be conducted in multiple stages, especially if the excavation depth is significant. Upon completion of the initial phase, we proceed to establish horizontal wells with a diameter of 15 centimeters. These wells are meticulously drilled into the walls of the excavation, attaining depths ranging from 5 to 10 meters. After preparing the foundation, we carefully place the rebar inside each well to ensure proper reinforcement. Next, we pour concrete at the bottom of each well. Once the concrete has set and hardened, we apply tension to the rebar and connect it to specialized panels that are strategically positioned between the vertical supports. This meticulous process ensures the structural integrity and strength of the construction. The next solution involves using a tie-back retaining wall system. In this approach, we excavate the first 2 meters without any special measures. Following this, we drill horizontal wells into the newly created walls and insert steel cables into them. Afterward, we pour concrete at the end of each well. Once the concrete has set, we tension the steel cables and fill the remainder of the well with concrete. Finally, after the concrete hardens, we secure the steel cables in place using specialized fittings. This process generates a force that compacts the surrounding soil and stabilizes the pit. Depending on the height of the excavation, this procedure may need to be repeated multiple times. Another method is known as the steel strutting system. In this technique, wells are dug around the excavation site, with a depth that is 25% greater than that of the excavation itself. Beams are then placed within these wells, and several steel plates are installed at their ends. These beams are concreted using specialized equipment. Up to this point, the process resembles that of the anchorage system. However, once the beams are in place, we connect them face to face in pairs using various types of trusses or steel beams. We are in the process of excavating the area gradually, with the ultimate goal of reaching the final depth of the pit. It is crucial to be aware that this particular excavation system is not recommended for use in areas wider than 15 meters, as doing so may result in significant complications. Another method is known as vinyl sheet piling. In this system, specially designed steel sections with a thin profile are driven into the soil at the excavation site using specialized machinery. These steel sections feature interlocking connections and are paired together to form a continuous barrier. After the excavation, the next step involves implementing braces to minimize pressure from soil movement. However, the most common and cost-effective method for excavation is the truss system. In this approach, we first dig wells along the sides of the excavation and install steel reinforcements at the bottom of each well. Next, we place beams, to which several steel sheets have been welded, into the wells and then concrete this section using a tremie pipe. We excavate at a ratio of 1 to 2, for instance, for a height of 10 meters, we would excavate 5 meters. This process continues until we reach the specified depth. At that point, we construct a foundation for the inclined member of the truss. and then we install this inclined member in its designated position. As we continue to excavate the remaining areas, we also place additional diagonal and horizontal members of the truss until we achieve the desired depth. The system is simple to use, cost-effective, and can be implemented without the need for specialized personnel. It's important to note that multiple excavation systems can be used simultaneously or in combination, depending on the specific conditions of the project. Thank you for being with us. I hope this tutorial was useful for you. Don't forget to follow our channel to see more videos.